Find the limit. The limit as x goes to infinity of the square root of x squared plus 4 divided by x. Now if we try to evaluate this using the quotient rule, as x goes to infinity, x squared is going to go to infinity. It gets larger, plus 4 gets larger. Square root is also going to get larger, so that's going to be infinity. And of course, as x goes to infinity, the denominator, which is x, goes to infinity. So we could see this as an indeterminate form, and we could try to apply L'Hopital's rule to it. So by L'Hopital's rule, we get the limit as x goes to infinity of the derivative of the numerator. X squared plus 4 to the the square root of x squared plus 4 is the same as x squared plus 4 to the 1/2 power. So when you take the derivative, you get 1/2 x squared plus 4 to the negative 1/2 times 2x. Because of the chain rule, you have to multiply by the derivative of x squared plus 4, and that's where the 2x comes from, divided by the derivative of the denominator, which is 1. Now if you simplify this, the 2's will cancel, and you'll be left with the limit as x goes to infinity of x divided by the square root of x squared plus 4. The negative exponent drops that factor into the denominator, and the square root is that 1/2 power. But now you see that we're basically going to be in the same situation. We're going to have an infinity over infinity, and while we can try L'Hopital's rule again, we can imagine, just from what we've already done, that we're just going to get ourselves back to where we started. So that's not going to get us very far. So you have to be a little tricky with this limit. So let's start again. This method doesn't get us anywhere, oddly enough. The thing to do is to use some algebra for this problem. Namely, x is the same as the square root of x squared, as long as x is positive. And as x goes to infinity, x is positive. How does that help us? Square root combines or breaks up over fractions. So this becomes the same as the limit as x goes to infinity. The square root of x squared plus 4 divided by x squared. So now if we try to take that limit, the limit of a square root, since the square root is a continuous function for positive values, the square root of the limit. If we try to evaluate the limit inside, we'll quickly get infinity over infinity. So we apply L'Hopital's rule to that limit inside. So we still have our square root, but now by L'Hopital's rule, the limit on the inside becomes the limit as x goes to infinity of the derivative of the numerator, 2x, divided by the derivative of the denominator, which is also 2x. Those cancel, and we're just left with 1 divided by 1. The limit of 1 is 1. The square root of 1 is 1. So our limit, finally, we find that it's equal to 1.